So Coleman, you sent me an email, and in that email there was an attachment, and in that attachment there was an article.
As I do.
Yes. Do you remember this?
I do. Slightly.
So this is interesting. I mean, I guess we shouldn't be too surprised about this happening. You know, bad guys like to take advantage of bad stuff happening to everybody else. Create a lot of noise, maybe disguise, what you're trying to accomplish, cover your tracks a little bit. But this COVID-19 alert that came out from CERT yesterday was kind of interesting. So you kind of had a hunch about maybe what traffic was looking like in the Gov Cloud environments, and you had something already spun up in Gov Cloud. Do you want to talk about that a little bit?
Yeah, so I mean, we have a lot of event-driven things that happen, and we're fairly used to them, like phishing and malware and those sorts of things. This is a pretty significant world event, and what really stuck out was we've got a lot of customers that are looking at telework now. So the big one was the exploitation of teleworking infrastructure. So we've got a lot of customers that are setting up new VPN endpoints. We've got customers that are setting up new RDP endpoints and things like that. So that's one of the massive things. And there's been reports on, this. I sent you this email so long ago. I think it was yesterday. And in that time, there's, since all the things have been going on, we've seen about 127% increase in exposed RDP endpoints that are not protected. So in the environment that I stood up, normally we just refer to it as a secure cloud architecture that lives in the public cloud that provides our customers way to access stuff. I started attaching sort of just, we'll call it a honeypot. So essentially just stood up Juice Shop and put it behind our big IPs and just started looking at traffic. So you pulled up basically what it cost last month for me to run our entire infrastructure. So this is an entire security stack in a Gov Cloud for the entire month of March. And you can see how it started to grow. So, it started off, generally I see when I don't publish any sort of applications and I just do sort of testing with a single endpoint, around $2 last month, it started to ramp up. So for the total cost of March, it was about $44. And then if I look at after setting up some security policies to monitor the traffic, I think you've got that to pull up as well. So right now I'm looking at about $1,500 in charges if I were actually processing the traffic that I'm receiving. And at the end of the month, I'm looking at an estimated almost $10,000 just for throughput. So this is pretty crazy.
That's
as far as
absolutely insane.
You get a reasonably priced car for that.
Yeah.
Yeah.
You gotta flatten the curve there, brother.
I'm trying to flatten this curve already. So this is not implementing any sort of auto tuning or denial of service protection. This is just looking at those sorts of attacks and traffic that's coming in. And this specifically around this deployment, we're talking about, I've got an RDP interface. I have some self IPs. I've got SSH. I've got a sort of my honeypot is Juice Shop. So it's a well-known OWASP application that generally if bots or hackers detect the system, they're like, oh, this is Juice Shop. I'm just going to ignore this because there's no real, I'm not going to get any credit cards. I'm not going to get any real user information. But you can see here, and this is just from the past couple of days, like the past week is when I turned on these policies. So it's hard to see in this screenshot here, but this just started April 3rd or 4th-ish. And you can see from where we hovered over here, my management interface for RDP has received probably the most requests versus Juice Shop, which is just a standard 443 application. So 229,000 ACL matches. So these are the amount of requests to my RDP interface that's published to the internet is pretty ridiculous. I mean, I'll log into this every couple of days just to check and see where things are at, but it's pretty wild to look at this.
So
go ahead.
I was going to say, if we correlate that with the press release, and the press release talks about remote access and teleworking, then RDP would be a method of teleworking, correct? You could have an RDP server that you connect to every day.
Yeah, I mean, a lot of our customers are just thinking we're going to connect to our standard VPN, but a lot of them are in that process now of setting up VPN and getting things moving. So probably the easiest path is to just deploy an RDP gateway or an RDP endpoint. I used to work in organizations that you'd have an IP that you could remote into the what do we call it, the TS server, this was just an RDP gateway that you would log into, and that was before the time of VDI. So there's organizations that they're like, oh, let's spool this up in the cloud environment, and we'll have a bunch of virtual machines. We don't have to worry about setting up VDI and things like that, just to get things going quickly. And it's pretty wild. If you evaluate a lot of the traffic, go ahead, Paul.
I was going to say, so, $10,000 bills aside, do we think these types of attacks are brute force attacks to try and get into that RDP server?
Predominantly, that's what I see. So if we look at the event logs on the big IP, we can see that these are actually coming in at the RDP brute force vectors, and that's pretty interesting to evaluate as well. But really what's crazy is that this is a private system that I deployed into a government cloud without publishing the IP. I'm not advertising this. It's not documented anywhere as, hey, here's my public IP for you to access to view this demo. This is something that I spooled up last week to do standard regular testing of our deployments in public cloud, and thought, oh, well, let me attach some policies to sort of capture the traffic. So it's pretty wild.
So what about attribution? Have you guys got any idea about who this or these things, where they're coming from?
Yeah, I mean, so we know, geographically where the IPs are going back to, and it's the usual suspects. I mean, it's the ones that typically you see that launch attacks towards, the United States.
In United States government.
Yeah, we do see, in that distribution of IP ranges, we also see a large portion of US IPs, which usually points back, and this is research that F5 Labs has done for quite a while, but it usually points back to IoT devices that are compromised, and those are being used to launch attacks. We did see something that I thought was kind of interesting with respect to was a country. What was the country, Coleman? I'm blanking now. Latvia.
Latvia.
And we thought that was interesting. Like, wow, it's one we don't normally see. We followed the ASN record back, and it actually goes back to China.
What even is Latvia?
Yeah. So an ASN that belonged to China. So it was interesting. I mean, it's pretty anecdotal at this point because anybody could be in control of those systems. I know the one, and actually, I think Paul, you brought this up, that the Fox Kitten tool set.
Yes,
was interesting. So I didn't know a ton about that, but that turns out that's actually one that's used to do a lot of SSH and RDP probing, which seems to be in line with what we're seeing. So not sure if that could be what we're seeing there or not. So
yeah, I think that there was a report that was delivered last month by a group. I think, was it Clear Sky, something like that.
Yep.
Notified people about what this Fox Kitten advanced persistent threat was.
On a side note, I don't know if I took a screenshot for this session, but one of the most wild things that I found so far in this analysis is, normally I see general traffic. I see bots sort of scanning the F5s that I deploy in the cloud environments. But one of the things that was just ridiculous is we were having some problems deploying in some of the government cloud environments, just weird things that would happen, weird errors. And we attributed it to, there was plenty of compute resources available because we were familiar with how those environments work. We're familiar with the teams that run those environments. So that was one of the other things that I wanted to evaluate was, what does it look like? Because these IP blocks for the public clouds are published publicly. so that everybody can see. And what does it look like as far as API traffic? And one of the most insane things that I found so far is a system that I so a system that I started logging access traffic on Thursday, I think it was, is I've seen 37 million layer 7 requests to those systems. Now there's some things that are very blatant. So out of the box policies are all I use for these configurations, auto tuning, no learning scenarios. It's only dropped about 47,000 that it just said, these are way too malicious, I'm going to drop those. But I have never in the history of deploying applications in Gov Cloud for testing purposes, have I ever seen 37 million requests in about a 4-day period. It's ridiculous.
Yeah, that's absolutely insane.
I mean, I'm not running Amazon. I'm not running.
Right.
I'm running Juice Shop.
Yeah, I'm not running Netflix. I'm running Juice Shop on a non-published public IP. So it's a public IP. I just put an application on 443. I've also got SSH and RDP published that go through a security stack. And 37 million is just insanity to me. Like I don't think in the amount of customers in the 9 years that I've been at F5, I don't think I've seen any security logs that have shown in a week 37 million requests for our customer base anyway.
So I guess it begs the question, how do we protect, if this was a real world scenario, you want to prevent this from happening. So how do we protect against all this traffic?
Yeah, so mitigations was one of the things I wanted to hit on. So there's several things that we can do on the big IP, which I think are entire sessions on their own. How do we properly tune ASM to protect against the web applications? How do we properly tune AFM, which I think is super critical, because how do we protect against all of these RDP attacks, which are happening consistently? And then you've got the normal stuff. Like we need to ensure that we've got bot protection. We need to ensure that we've got DOS protection in place. And we've got a lot of tools to do that. We've got Shape that we can implement some enterprise defense. We've got mobile defense. We've got a lot of toolkits there that we can implement. Sometimes it works extremely well when you combine that with big IP. So you can just basically copy and paste an iRule on your virtual servers that will tie you into Shape security. But the big one, I think, is just properly tuning and configuring AFM, ASM, bots, and DOS. And
sure.
Yeah, I think sometimes, we look at, you've got some of that. So if I look at a Pago image, I can do a lot of that out of the box. But if I look at, do I want to implement AWAF? And AWAF adds a lot more. Like I can do threat campaigns. I get bot signatures and things like that I don't normally get out of the box with a Pago image in some of the public clouds, which I think is important is an important differentiator for a lot of our customers of why would you evaluate a subscription or ELA or a perpetual license? What additional attributes and protections do I get? One of the big ones with SCCA, the Secure Cloud Computing Architecture requirements, is with a Pago image, I get protection, but I don't have things like IPS, and I don't have those 0-day database updates on the big IP that I think I would want for things like what's happening now.
What about, I keep thinking about two-factor authentication, right? So, I mean, that seems to me that would be a really good way of at least preventing a brute force attack. I mean, there's a lot of computational stuff going on with, and that can be mitigated with the WAF and the firewall.
And I think that's a massive place where I didn't even put in protections. Like I didn't implement APM because it's Juice Shop.
Right.
But if this was like an application, like we build a real honeypot and we put a login with real credentials, I'd want Blackfish there. But if I'm looking at CAC or PIV or anything with multi-factor authentication, that would definitely be a massive block, because as soon as, and I've done it, I've written bots before that do war dialing on the internet. I didn't say that, but I've
We'll edit that out.
I mean, it's very simple to edit that out. It's very simple to write a bot that will scan the internet, and as soon as it detects the mutual TLS request, the bot dies. So a lot of these attacks that we see are bots. So as soon as they detect that MTLS request for a client certificate, they just drop out. They're looking for a login page that they can subject.
Log into. Yeah.
Yeah, so they can subject some credential stuff to attack and things like that. So APM would be a massive protector here. But since it was Juice Shop, I didn't even implement it. But that would definitely be something that we would see. I'd see probably thousands of attacks on APM or thousands of login attempts.
Sure.
Now you mentioned Blackfish, which I a lot of people may not know what that is. So who wants to kind of talk about Blackfish for a second and talk about what that does? Anybody?
I can do it.
Okay.
And hopefully I get everything right. But so Blackfish is basically a tool that we now have under Shape Security that allows you to verify compromised credentials. So Blackfish goes out and it retrieves all of the compromised credentials, username and password dumps out there on the internet, on any of the paste bins or any of the dark web, and it stores everything within a Bloom filter so that you can verify as users are authenticating to your applications. You can verify a compromised username, compromised username and password against what's being presented to your system. A lot of times our specific customers for our industry and Fed are using CAC or PIV, so it may not apply, but there's also use cases that we could implement that we could verify after a user authenticates to their Active Directory or whatever their AAA solution is. And we could verify any of the usernames in there and say, oh, this is a compromised username. So we can say, oh, this user might have a higher risk level than somebody else within the system.
Well, I think about like anything that's public facing, so user, citizen facing. So if I'll IRS as an example, right? Tax season's coming up, delayed, thankfully. But those are credentials that don't use strong authentication typically, right? They're going to be a username and password and maybe some kind of multi-factor that's probably going to be weakish because it's got to be something that a customer or user has. Those types of things are a perfect scenario where Blackfish could be implemented to screen those users as they log in, identify people with compromised credentials, and then have that user immediately change that credential or do something with that user so that it's not continually farmed and used.
Yeah, I think I talked about on one of our sessions recently where there was a very sophisticated phishing attack where somebody was able to impersonate the bank and they were sending the PIN. So they were somehow able to access that user's compromised credentials, but they didn't have that 2FA. So they're able to say, okay, well, I know his username, I know his password, I just need that 2FA. So let me send an SMS message to his phone, get him to send me that PIN, and then I can authenticate into that system. So there's several, especially now we're in tax season. We've got an extended tax season because of the current situation. So that's definitely a place where something like Blackfish could absolutely help.
So Blackfish then is a huge database of compromised usernames and passwords, correct?
That is correct.
I wouldn't call it huge because it's using a Bloom filter. So it's basically just an algorithm that stores a hash.
Okay. Yeah.
So that's
what it does is big, right? So it maintains a corpus of large data sets, but it's efficiently packaged.
Right. Fair enough. But okay, so we're trying to protect against credential stuffing, like brute force attacks, right? So you've got bots out there on the internet that are searching for login pages and sending effectively lots of compromised usernames and passwords to those servers. And if you're using the Blackfish database,
I think one other big thing that we might have missed so far is API security.
Mm-hmm.
So I've got at least weekly calls and text messages from our friends over in these cloud service providers, and every time there's an issue they hit me. And then this deployment, this use case, and this honeypot helped me sort of identify the amount of traffic that we're seeing on these well-known IP blocks. And the way that these environments are controlled is if I want to deploy a specific security stack in these environments, I do it via API, whether it's through Terraform, whether it's through a CLI, whether it's through a GUI interface in these CSPs, it's still accessing the APIs of these environments. And if these APIs are flooded, then it can cause any number of deployment scenario issues. So that's one of the big things that we're seeing as well, is this API protection. And I think that's one thing that we aren't super intelligent on in the way that we do things in federal yet, is protecting APIs. Like it's
Sure.
that I've seen used, it's growing exponentially, but traditionally over the past 9 years, it's not something that I've seen a tremendous amount happen on. And it's something that we heavily rely on, especially as we're moving to these environments. Like if we talk about Terraform and we talk about Ansibles and we talk about all these other tools for automation orchestration, they're all using APIs. So if I'm deploying to any cloud provider, whether it's public or private, and I'm using something that accesses APIs, if it's public facing in any way, there's a chance that these systems are being exploited or DOSed. I think one of the things that, tied to that I forgot to bring up was that, where is it? I had a note here. There is currently a pay for service, so discounted off the shelf malware. So there's offerings on like a lot of the dark web marketplaces for, so apparently there's over 500 posts right now, the last time I checked, where there's coronavirus discounts and promotional codes for DDoS, spam.
Coronavirus special.
Yeah, coronavirus malware. So specific solutions that are like, you get a phishing email that says, oh, you need to download this Zoom update, which now you download this Zoom update, which has a bunch of malware and ransomware and whatever else installed based on the current situation. So it's pretty wild.
Illegitimate Zoom update, it should be noted.
Yeah, illegitimate Zoom updates.
But you can attack. Most of these APIs are running over REST these days, so I think you can attack the APIs.
And they're publicly available. So I can go out and I can say, hey, I need all of the Gov Cloud APIs for this cloud, and I can download a JSON that has all of those public IPs available.
So there's a pretty interesting website. It's an API directory. So I did a search just for government APIs, and 72 pages of about 10 per page, just 720. Math is hard.
The USPS tracking API. I saw a follow the money API down there somewhere.
Right. Yeah. So some of these are government focused. Some of them are run by government. So kind of interesting. But yeah, I mean, these things are pretty well published and pretty well known. There for our convenience, but also the convenience of the attacker as well.
Words are hard.
Words are hard.
Words are hard.
So if I was a bad guy, I could go there and look at an API and figure out how to attack it, right? So
well, most APIs have a query that you can just send that will give you the proper structure of that API.
Yeah.
So if I just do a get versus a post or whatever, it'll say, oh, you need to submit this format.
Yeah.
And, Bill and I, mostly Bill, went through all of the ICE APIs recently just to kind of evaluate how do we structure things there. And it took Bill about a day to kind of figure out how to loop through and get everything he needs from that API. So it's not hard. And as we move more towards an API driven sort of industry, a lot of organizations are using things like Swagger. So there's organizations that are posting their Swagger files on GitHub. So I've got the entire source for your API off of GitHub.
I know with ASM, you're going to be able to import a Swagger file and thereby help to, it's going to enumerate the API, and from there you can start to protect the API, right? So you can.
We've got ASM and APM are targeted for API protect, so you can sort of build the structure around. Here's the entire API structure. Here's the authentication tied to that. Here's what we accept as the structure and the schema and the stanzas within that API that make it pretty handy to have available. I think that's all the big bullets I had, unless you had any other screenshots that we forgot to bring up, Bill.
I think I covered them all.
Are we going to have something to play us out?
We'll do it live. Do you want Sting to do
a dance of the COVID-19 situation we've got.
I mean, I like to end with a call to action, and I think our call to action for our customer base is just to reach out to us and ensure that you've got some protections in place. And if not, let us look at it. Let us turn on some logging and just see what you can do to patch some of that, because you might not have to buy anything. You might just have to turn something on, which we find with a lot of customers. I don't know if you guys had anything to add there.
I think you hit the nail right. I mean, we're definitely we've been helping a lot of our customers recently with the things they're going through. Obviously, the increase in telework has been a pretty big strain on everyone. So we're definitely helping customers deal with that. And yeah, Paul.
Yeah, I was going to say we can help you with remote working solutions and increasing and making your remote working solutions performant. That's kind of what we do. And also we focus on security. So we've been talking about all the things that we can do from a security perspective. And that cert that came out, or that press release, was in the realm of security and attacks against things like VPNs and RDP, remote access solutions.
Yeah, I was just thinking one other thing that might be handy to some customers is it might just be as simple as renewing a support contract to update the SKU on your platform, because we've recently removed a lot of the limitations around access sessions and things like that make per user concurrencies a lot easier to accomplish. So that could be something to look at too. I mean, it could just be as simple as calling up your F5 team and saying, "Hey, can my system be better?"
Yeah.
Yeah. You guys haven't talked to us in 2 years. We've had a significant number of changes. All you have to do is re-up your support, and boom, Bob's your uncle. There you go.
Bob's your uncle.
I mean, technically, Bob is my uncle.
Awesome. Well, hey guys, thanks for dropping in and chatting about this stuff. It was pretty good. We'll have to do more of these.
Yeah. Thanks a lot. Cheers, guys.
We'll see y'all.
Bye.